Now children, proving De Morgan's law in a general method. Okay, so listen to this part carefully. Now one of the De Morgan's law says if we take union of A and B and then take its complement, or we take intersection of A complement and B complement, both the sets will be same. Once we'll do them theoretically, then we will try the same thing through Venn diagram also. So what I need to prove, when we were doing the definition of proper subset, we discussed for two sets to be equal, like two sets are A and B, they can be equal if A is a proper subset of B and B is a proper subset of A. If this is maintained, then they both will be equal to each other. So I am going to prove this set is a proper subset of the set on the right hand side. In the same way, the set on the right hand side is a proper subset of the set on the left hand side. Hence, they both will be equal. Okay, so let us start. In order to show one set as proper subset of other, we need to show every element of one set is also an element of other set. So keeping that definition in mind, we proceed. Suppose we take an element in the set on the left hand side. So I have taken X belonging to the set which is complement of A union B. Now recall the definition for complement. If X belongs to the complement of this set, that means X will not belong to the set A union B. You can quickly perceive, suppose this is A union B. And when I say it is in the complement, that means it is here. The element is X is here. So if X is here, it will not be in A union B. So when I assumed X belongs to the complement of A union B, we can surely say X does not belongs to A union B. Now you think under what condition an element cannot be in the union. What the condition must be so that it is not coming in the union. See again, if this is A, this is B, then the union is entire thing and X is not coming there. So X is not in the union, that means X is somewhere over here. So what can we say? This means what? X is either X is not in A and X is not even in B. Only if it is not in any of these sets, it will not be in their union. Because in order to come in the union, the element should be in one of the sets minimum. Only if it is not in any of the sets, it will not belong to the union. So because I know X does not belongs to the union, that means X does not belongs to A and will come here. Compulsorily, it is not belonging to B also. That is why it is not in the union. Now further rewriting this step in a different way. If X is not in A, then where is X? It must be in the A complement. In the same way, if X is not in B, where it must be? It must be in the complement of B. So what do we have now? X is an element which belongs to A complement and X belongs to B complement. What is this definition of? This is definition of intersection of two sets. So therefore X will belong to the intersection of these two sets. Now you see we started from here and we are ending in this set. So X was initially an element of complement of A union B. Now it is an element of A complement intersection B complement. So we can say A union B complement is subset of A complement intersection B complement. That means we have shown this is a subset of this set. Let us do it other ways. So I'll start from this set. Suppose Y belongs to A complement intersection B complement. So using the definition of intersection of two sets, we can say Y belongs to A complement and Y belongs to B complement. Okay. If Y is in the complement of A, that means it is not in A. In the same way, if Y is in complement of B, it is not in B. Now see here. If Y is missing from A and it is also missing from B, that means, what does it mean? Y is not in A, Y is not in B. So even it must be outside both. That means it will not come in the union. Y will not belong to the union of A and B. And if it is not here, then where it is? It must be in its complement. So we started with Y belonging to A complement intersection B complement, and now we are getting Y belongs to complement of A union B. That means this set is a proper subset of this one. Now you compare first and second. You will see both the sets are proper subset of each other. So we get this result. Clear? In the same way, the second one can also be obtained. I have written it here. You will quickly go through this. Then we can try them in Venn diagram also. See again, starting from here, X is taken as an element of complement of A intersection B. That means X is not in A intersection B. If it is not in the intersection, which elements come in the intersection? X will come in the intersection if it is in A as well as in B. And if it is not coming in the intersection, that means what? It is missing from one of the sets or it is missing from both. So when I say X does not belongs to A intersection B, that means X does not belongs to either it is not in A or it is not in B. That is why it is not in the intersection. So if X is not in A, where is X? It is in A complement. In the same way, if X is not in B, it means it is in B complement. Now look at this and recall the definition of union. So X belongs to A complement or X belongs to B complement implies X belongs to the union of both these sets. So earlier X was element of this set, now it is an element of this set also. So complement of A intersection B becomes a subset of this set. Fine. So we know this is proper subset of this set. Try it other ways also. So starting from here, suppose Y belongs to A complement union B complement. Then using the definition of union, we can write Y belongs to A complement or Y belongs to B complement. Now if Y is in complement of A, that means Y is not in A. In the same way, if Y is in complement of B, that means Y is not in B. So now think, if Y is missing from A also or it is missing from B, then to which set it will not belong? Can we say Y will not belong to the intersection of A and B? Let us see how. Suppose X is not in A, obviously it will not come in the intersection. Or suppose it is in A but it is not in B, then also it will not come in the intersection. And if it is not in any of these sets, then also it will not come in the intersection. Only in case it is available in both the sets, then only it will come in the intersection. So if Y is not an element of A or it is not an element of B, we can say it is not an element of A intersection B. So it is an element of which set? It will be element of complement of this. Fine. So Y was earlier belonging to this set. Now it belongs to this one. So we can say A complement union B complement is a proper subset of complement of A intersection B. Now you compare again 1 and 2. You will see both the sets are proper subset of each other. So they have to be equal to each other. Now I will solve the first one using Venn diagram. In the same way you can do for the next one. Okay, look at this. We will do the left hand side first. Say this is our universal set with set A, set, okay, let us keep something in their intersection. This is set B. So first I will shade A union B. This is all A union B. Fine. So this portion is showing A union B. So where is left hand side is what? Complement of A union B. Which part is complement? The blank part. That means the part which is outside the shading. So this is A union B complement. So left hand side set we can see where it is. Now moving on to the right hand side. Let us see, does it denotes the same portion? So this is A, this is B. I will shade complement of A. Complement of A means outside A you have to shade. I am making these vertical lines outside A. So this is all A complement. So these vertical lines are denoting complement of A. I need B complement also. Then we will see what is their intersection. Let me take horizontal lines for B complement. While doing B complement, I will not shade B because it is outside B. Okay, so B complement is also done. The horizontal lines are denoting B complement. You have to take intersection of these two. Which portion is denoting the common area of these two? Means the area where you are getting horizontal as well as vertical lines, that will be the intersection of both. Okay, so trace, where is this portion? Is it same as this blank portion or not? See, all the checks are outside A and B. This is denoting A complement intersection B complement. Now you compare both. Is this and this region same or not? You will find, see, this is all unshaded part. And these shading where both the lines are there, that is denoting the same part, which is same as this region, which is denoting A union B complement. So exactly in the same manner, the second law also can be